I think now's a great time to introduce yourselves, and then I'll tie it back together and what forced you all to get on planes to come back to Austin. And it's my fault, but hopefully this will be the reason that we get to reintroduce this. This was one of the most important panels, right? And I felt that it was so important I could anchor everyone around it. And then I underestimated the power of an open bar and fun, right? So honestly, the genesis of that led me to believe like, okay, now I need to have 2 days of content, but I'll still modify or hybrid. There's a certain cutoff point that you have in those conferences where you just start losing people. But this one is the one that I was probably the most excited to hear most about. So before we get started, how about you, Liz? Why don't you go first? Ladies first, and we'll go all the way around the horn back to me.
Great. I'm Liz Cruz, and currently the Director of Product Marketing at Accelsius, which is a liquid cooling company that does two-phase direct-to-chip. But before that, I was an analyst for 10 years looking at the data center space, and then a little bit of time running Data Center World and AFCOM, the organization that's associated with it.
Wow. Big shops. I got you. How about you, Handsome?
Yep. Thanks. Rob Coyle. I'm the Community Technical Program Manager at the Open Compute Project.
Sounds like a big deal. Big title. Seems like a big deal. He's like
Just
the Ron
a lot of
Burgundy of
words.
Open Compute.
I mean, the hair's certainly Ron Burgundy.
I know, look at that
I'm just
guy.
waiting for the mustache and the
Look at that,
beautiful
dude.
suit
It's a
this
sin.
man could support it.
Not supposed to be that smart and that good looking.
All day.
Dean.
Hey, Dean Nelson. I'm the CEO of Cato Digital, startup company doing low cost, low carbon bare metal, and the founder and chairman of Infrastructure Masons, our community organization that is uniting the builders of the digital age on a greater digital future.
And you guys started, what's the big thing that you're trying to get everybody to buy into right now? I know that most of us, go ahead.
The Climate Accord?
Yes.
Yeah, absolutely. And we have 250 companies, and now it represents over $6 trillion in market cap. AWS, Google, Meta, Microsoft, and every other company you could think of are actually there to decarbonize digital infrastructure. And so we talked about this on another podcast, and it's just so cool to watch how this all came together. And Bill and I were at the initiation of that at Christian Blatty's house,
Seattle,
right?
That's right.
It was just so amazing to see something that was an idea to say, let's find one thing we can do together. And then it turns into a movement, and then you get adoption by the biggest companies in the world that actually care very much about the mission, which is to decarbonize. And we're just making great progress.
Yeah. And Infrastructure Masons has really been pioneering a lot of those things that we do in the industry globally. So it's an honor to have you here too. Go ahead, Wonder Boy.
Oh my gosh, it's the hat. That's why it's the Wonder Boy hat.
Did you buy that hat in Austin during one of the conferences?
I did. This is Alan's Boots hat, which
Beautiful.
is one of my favorite places. If you're going to go there, get your boots shined. I got some ostrich skin boots from there.
Boy.
Holy
I tell
cow.
everyone, I'm like, if you not bought boots, you have to go to Allen's downtown.
That on Congress. I mean, that is the place for boots, ladies and gentlemen.
It's an
if you're
institution.
going to go out there, I mean, this is a totally shameless plug for and a great experience. But I'll tell you what, they make sure that those boots fit. These aren't the ostrich skins. These are my Tony Lamas. These are comfy traveler's boots.
I got you, because you are a world traveler these days. I see you all over the place. Where's Waldo?
It feels like that. I mean, I don't know where Waldo is. At this point, the picture is so blurry, you can't even find him. I mean, he's wearing whatever. Thank you so much for having me here. I'm Bill Kleyman. I am the board member and lead technologist over at a little company called Neu.ro. And we have an extraordinary solution. We are an interoperability platform that is currently the only one that's capable of literally converting any data center with any access capacity to become an AI data center. So in the next 5 to 7 days, as long as you have GPUs or CPUs, you can literally become a competitor to Amazon, and it's your logo and all of that. So we've been quite busy. I work closely with Dean Nelson over at Infrastructure Masons. I'm the education chairperson, and I get a chance to work with just brilliant young minds, just folks that are in the electrical, computer, mechanical engineering space that should be in our industry, but don't realize that they don't have an opportunity, or maybe just didn't realize how they could apply their skill sets. And then outside of that, I am the chairperson for the flagship conference here in the United States for the data centers. That's AFCOM Data Center World. This year it's going to be in Washington, D.C., literally the day after tax day. So I've got like a list of jokes. I mean, I don't need to go into politics. I mean, tax is like for half the setup. So that's really exciting. And then I'm also contributing editor to Data Center Knowledge, Data Center Frontier, and a few other industry publications.
Yeah. Just to say a few, I guess. So to bring that all back together, right? We have a lot of power, a lot of horsepower here today. And it's because the genesis of this, right, was I asked you all to take this topic forward at DCEC Live this year. The most prevalent topic was probably power, right? And we talk about the demand for power from cloud. And then the most prevalent term that's emerging and the primary focus of DCAC Live next year will be on AI and the impacts that it's making on everything. But the reality is we don't have enough power to support the growth of cloud, which is where you guys are getting into your innovation and what you guys are doing in open compute. And then now this will parlay into a longer discussion that takes us back full circle back into power, which is in following podcasts, this should be the one that really helps people understand the magnitude, because I think if I had ran with this panel first, I think it would have blown the doors off of everybody, because people know AI is prevalent and they know that it's coming, but they don't understand the magnitude of the impact that it will make, nor do they understand the challenges that we face to liberate AI to those that really want it and the concerns that we have with it, right? And I don't have enough knowledge on that. I'm like, as I'm listening to you all talk about all the things that you did, I'm just a caveman compared to some of the things you've done. I've built space power and cooling to support these environments, but when we talk about what happens inside the white space, I really need help. And I'm going to be the one that I think, I'm not saying I'm common, I'm saying more people probably are in line with me on how much they know or don't know about AI. And I hope that this podcast is an opportunity to reset that, because we'll never again take something of this importance for what we're doing in the industry and make it the last. It was a calculated risk and I failed. So to that end, thank you everybody for having the patience to come back and let's take this back around the horn. You were doing a great job kind of moderating it. Not that I won't try to help facilitate some of these questions, because I'll have a few that I think some of the people that are listening that spend more time around space power and cooling, they don't understand the white space as much because they feel like they don't need to. And I'm like, those days are over in which you could come in and just be a siloed subject matter expert on one element of our industry. You have to broaden your knowledge and you have to know more about everything that's coming. And from everything I've seen, AI is going to rip off the head of cloud's demand. And we aren't prepared for what cloud's demand is yet, right? So I want you guys to take us back to some of the things that you're seeing and what you feel is going to be something that someone that's listening to this is going to walk away and be like, hey, I think I understand what I need to do with my career, because I'm not positioned in a place right now where we're going to be successful. Maybe we are successful today, but in a year from now, I may be getting outflanked because I don't have the skills or the knowledge to be able to adapt to the demands of the industry. Does that make sense?
It does. It does. I mean, I'd love to kick this off. So over at DCAC, I was the moderator, right, and I had a chance to speak with these three wonderful people. For everyone listening, there's a reason these three people are here, right? So Dean's Cato architecture is a full rack architecture and solution with GPUs built in. Just earmark that. We'll get to that. Rob does open compute OCP type of architecture that allows you to really broaden the kinds of technologies you can put into a rack. And then Liz supports the liquid cooling architecture. So we have the racks, the compute architecture, and the cooling part of it, right? For everyone listening, it's important to sort of wrap your head around what's happening in our industry. I think ChatGPT got to 1 million users in 5 days, 100 million in about a month, and about 9 months in, they were about 1 billion unique users. The only other application that came close to it, drumroll, was Threads. Threads actually hit 1 million in about an hour, but that was it.
Is that a direct messaging app on Instagram? That's what that is,
how
right?
well you're right.
Okay.
You know, post people like, what is Threads? I don't even know that.
Yeah.
It got up top and then it kind of fizzled out because people are like, this is just, Twitter 1.2 or something, X, whatever you want to call it. And so we got up on the stage to discuss, these really critical technologies and how we all support. And what I want everyone to understand here for just a second is that the biggest shift that's happened in our industry, in our world, is that humanity is experiencing a fundamental shift in how we work with data, how we ask data questions. That's it. It's as simple as it's going to come. For every single person on this podcast that's listening right now, if you've gone to Google or if you've gone to Bing and you've typed in a question, we've been conditioned to, type in a question and we get a pretty blue link, right? God forbid you end up on page 2 of Google. No one belongs there. That's like Mordor. But when you get to page 2 of Google, you're really kind of lost. So we've gone from getting that simple blue link to conscious answers, right? So if you've gone on Google or Bing in the past 2-3 months now, I believe it is, the first response you get is not a blue link anymore. It's a generative AI response. So every single person listening to this podcast right now
is feeding it,
is a user of generative AI. Now, that is where this this pinnacle of a conversation is happening in terms of what actually supports it. So Neu.ro is the interoperability layer. This is my infrastructure that I deploy upon, and OCP are the servers and infrastructure that I use, and Liz's architecture is the cooling environment that we've been working on. The dominant model that we've seen transitioning from legacy data centers to modern ones, and Peter Gross, I'll give you a big shout out for this statement. The data center industry loves innovation as long as it's 10 years old.
Yeah.
We don't have 10 years. We don't have 10 months anymore, right? We are already losing this race to the giant hyperscalers out there. And data centers, once again, are relegated to traditional workloads, right? VMware, Citrix, traditional Exchange servers and databases, where we actually have an opportunity here to capture this market, this giant pie, to democratize it and support it. That's why these people are here. Just to be very clear, is because these technologies are powerful in terms of it's not just AWS. Sorry, anyone at Amazon listening. It's not just Meta. It's not just Microsoft, and it's certainly not just Google. And that's kind of what's fascinating here. And Dean, I'll pass this around the horn a little bit, but Dean, you've had this opportunity to sort of enter this market in, and we've used your ecosystem quite as well, where you.
Yeah, so Cato Digital is basically bare metal, and what's differentiating about us is that we're using Open Compute Standard Second Life equipment, and this is important because we're not doing net new servers. We're actually taking equipment that is being retired from hyperscalers that's on a standardized, scalable infrastructure, which is all OCP based, and we're recertifying them. Okay, so this is like a recertified BMW. Thing still goes really fast from A to B, right? And the key here is that we take this capacity and all the engineering and heavy lifting that's been done by the hyperscalers, we're leveraging that. And then we're using this waste stream of their retirement to turn into a supply chain. That supply chain, then we go back and use the wasted capacity in data centers. So this is the stranded power that we have all over the place.
Is it being used specifically for one workload, and that's AI?
No, this is
for that? Okay.
We have three offerings within the platform. So it's basically application servers, storage servers, and GPU servers. And each of those are important because they're the basis for the probably 80% of the work that happens on the internet. Okay. Application servers are basically running a bunch of types of application things that are ephemeral. What that means is I can go back and send something out, and if it goes away, I can do it somewhere else. Like a search moves around to wherever it's available to be done. Then you've got storage, which is more persistent. And so people use multiple servers from us to create storage services on top of it. So even though our servers are a 2.5/9 SLA, right, they can go away. They get 10 of them, and all of a sudden you could have 3 go away and you still don't lose data. So we've got high performance storage in those actual servers themselves that now is striping the data across all of these systems. And so people are able to create these platforms and offer to their customers via that hardware. Then the third is GPUs. And so the GPUs, we're using V100s. And I want to be clear on this. Everybody's, it's insane. Everybody's going after H100s, A100s, A10s, T4s, all the latest and greatest GPUs. The thing is that, I don't know if you've seen the lead times, but the number 1 and number 2 buyers of NVIDIA H100s are Meta and Microsoft. 150,000 each, right?
Singapore has got 15% of the entire market. If I'm not mistaken, NVIDIA shipped 900 tons in Q3, and they're still not meeting demand from the market.
Do you notice in tons, not in units, in tons?
Yeah.
So that's all net new capacity. But the thing is, we're all racing to use the Ferrari to go to work. That analogy really, really resonates with me because I'm sorry, but 80% of the work done in cloud today doesn't need all this latest and greatest stuff. But we need those cutting edge pieces of it because there's certain things that are really time sensitive that really have to do large models that have compressed timeframes. But the rest of the work can be done on these workhorses. And so that's what we've really aligned on is V100s in 8-way configurations. And these are standardized OCP configurations with NVLink on them, right? 512 gig of RAM, dual socket servers, and then we've got 4 terabytes of NVMe on it, storage. So everything is lined up to be able to say I can do lots of models into the system and swap in and out of GPU memory very quickly to be able to go back and do the workloads. So our whole goal here is how can we go back and take this second life equipment and provide standardized scale capacity across those 3 product types to 80% of the market. And by the way, It's in all these stranded power and data centers. And
so that you don't have to just limit what you're doing to the large aggregators or buyers. You could go to the operators themselves and figure out when their clients are retiring gear. You could how do you get access to this? And at some point, I want to understand, like, if you're getting those workhorses, will you see that some of those hyperscalers decide that they want to hold on to those workhorses a little bit longer, and they see what you see, and they figure that they can distribute those loads differently?
This is a very interesting dynamic because the hyperscalers are just trying to keep up with their own demand.
I see it.
And when you think about, they already do extend their life. They have 5 to 7 years that they're using this equipment for. And then they have to retire it to be able to bring in the new stuff that's coming in. So there's at least a 2-year backlog of must retire equipment, right? Huge volumes of this come back out. And what we saw and why we dove into this was probably 70 to 80% of that stuff that goes into an ITAD vendor. These are the ones that handle the data basically collection and tracking and making sure that no data is lost, and then the recycling of it. 70 to 80% of it is going to scrap metal. Why are we taking the engine and the radio out and scrapping the entire car? So we want the entire car. And that's what we're really doing, is saying, this work's been done. Let's use this in another way. And the reason this is important is that it goes back to the original iMasons Climate Accord. We're all purpose-driven. What we care about is how do we contribute, right, to the community, to our planet, right, to the infrastructure, to all of our industry. And from my standpoint, what we can contribute is to build the most sustainable bare metal cloud in the world. Can we put 1 million servers and 1,000 data centers? All existing capacity.
In a sustainable way.
Nothing net new. This is the point. All scope 3. No new murals, no new manufacturing, no new processing, literally take what we have and use it. It's a simple thing, but it's like Airbnb. All those empty rooms in all those houses, we never used them. And all of a sudden Airbnb said, why don't we put them on a platform? And guess what? They're bigger than all the hotels in the world because they created a platform with all this excess capacity.
It's important to note that what Dean is talking about doesn't deprecate the experience. And so Neu.ro runs on Cato, right? So a client, for example, can go put in their logo and become literally a reseller of this capacity. V100s are about 1/3 of the power of an A100, but engineered properly, these technologies are extraordinarily powerful. So to the extent where if I remember correctly, we ran a GPT-like 335 architecture. We took a risk. We did a LinkedIn Live demo, and it worked out really, really well. And we ran like a Fibonacci sequence that we asked it to recode into like Python, I think, live, and it was doing it beautifully. And again, it's how well this model can predict the next piece of content, right? And so, working on Dean's architecture, you're not really losing anything, right? You continue to work with a powerful kind of ecosystem. So it's important to note also that the market itself is kind of interesting. So there's multiple different kinds of data centers out there. There's large wholesale data centers where, we haven't been able to sort of go into, not that we really want to either, because those large wholesale data centers, their number one clients are Amazon and Microsoft and Google. So like, I can't go in with Dean and be like, hey, put all these in here and start putting all your customers in there, because Amazon's gonna be like, whoa.
Well, they have one customer.
Yeah. What are you doing? You're competing with. So, but the retail facilities, what's been fascinating about what Dean and I have been doing is that we're not being driven by data centers. We're being driven by customers and end users, where they don't want to be, for example, in Amazon entirely. They don't want to be paying way too much money, where their information is potentially not secure, where their data is being used to train some other large foundational model. And so they go to the co-location provider and they say, can you give me something? And the usual response is, no, I don't know what to do here. Like, do I put some GPUs in? Because GPU as a service is cool. That's cool. But then you have to still go to the customer and say, bring your own tools, bring your own platform, build everything that you're trying to do. So what we've done is simplify that entirely by having D. Nelson and Cato's architecture, Neu.ro as the platform. And now all of a sudden these organizations, the cost is, and I hate,
and the speed.
I hate getting down to like the pricing of it. But we're talking about half or more. I mean, half or less than the cost of what it would be in Amazon.
Or like to like. Exact same systems running on AWS. Yeah.
What cost $40,000? We've done these comparisons. $40,000 in an Amazon architecture with SageMaker. That's their interoperability platform. Like 10 or 11 grand with Dean and Neu.ro on top of it. I mean, that is, and you're You're not losing anything. So what is being seen in the market right now is a new entry point, honestly, a new way to consume these technologies. Neu.ro was founded on 3 really important core principles: AI ethics, AI transparency, and AI sustainability. So working with Dean's architecture is critical for us because we have what's called a green scheduler, and people can actually modify how and when they're training their data based on electricity usage, the amount of time it takes. So, I mean, for example, if you span it out longer, it's going to show you've reduced your carbon footprint by this much because you're doing your engineering and training more intelligently. So I think
Like during off peak, you mean?
Sure.
Yeah, where the rate tables are cheaper. Is that what you're talking about?
Yep.
I don't know.
More
Yep,
wind
yep.
is blowing, more sun
Okay.
is shining.
Yep, it depends on the location as well. So I think the most important thing, and what we wanted to get out from when we did the DCAC live panel, was for everyone to understand that it's not just a hyperscale game out there. It really, really isn't. There are other really powerful players that are changing the game. The other challenge that Dean didn't talk about that I want you to talk about is density. I mean, the biggest problem for us when Neu.ro goes to a data center partner and says, I want to help you compete, they're like, great, Bill, we're at like 15 kW a rack. Or like 12 or 14 kW, right? Some of them are 20. I'm pretty excited, right? My previous employer, 55 kW air cooled, good for them. But you know that's not always the case. In a lot of situations, you have to just for context, an H100 is 6 units, okay, 6 units, and it consumes between 11 and 12 kW per rack, just one. So
it's like a huge space heater, and then I guess that's what Liz's company gets involved with.
Exactly.
It's a pizza oven, not a space heater.
Okay.
So how do you deploy it? If you're designed for like 10 to 12
massive.
kW rack, when you put one and a whole bunch of blinking panels, that's going to look horrible, and it's a completely useless waste of space. So in these situations, we've seen a transition. This is where I really want to bring Liz in here. A lot of the success that we've seen has been around single, two-phase immersion. Rear door heat exchangers are absolutely like the bee's knees. It's a weird one. I don't think I've ever used bee's knees in a podcast before. That's a first for me. But they are extraordinarily powerful because that allows for a truly hybrid type of architecture where you can have traditional air-cooled architectures. One of the best designs our partners has been successfully deploying has been a rear door heat exchanger with direct-to-chip liquid cooling. I mean, you're, no pun intended, you're double dipping. But in those situations, you're seeing this transition from an industry that's been operating at like, AFCOM State of the Data Center report, like between 10 and 12 kW a rack, to being asked to push like 60, 70 kW. Not everyone is ready for that. And Dean comes in here waving his flag. Dean?
And by the way, to connect these dots a little more, Liz is going to go into that 20%. Everything that needs the latest and greatest aspect of it. Right. And I really want Rob to go back and talk about just the open compute, because all this ties together with that standardization. But if you look at what we're rolling back out for that 80%, the maximum draw is 14.4 kilowatts. Maximum.
That's for the whole rack, the whole thing.
And if you look at those 6 units, you can have 8 of those in a rack. So 48 kilowatts is like the standard minimum measure you'd have on the latest and greatest, because you're putting H100s in density in those, and you just cannot cool that with air effectively. So that's where we need the next generation of cooling, right? So that's what Liz will go through. But I think what's important is that what we're rolling out is a highly optimized data center hardware configuration. So in other words, when we say 14.4 kilowatts, the average is going to be between 8 to 10, right? Depending on the type of workloads that are in there. So almost every data center in the world can accommodate it. So then you think back to that 80-20 rule again. We have all this stranded capacity. That's because densities are going up and efficient, right? Designs are not able to accommodate that type of thing, but there's stranded power all over. Excellent, then let's use it. So we take that and roll these second life servers back into those, but then you allow the colo, who right now is getting marginalized. Just think about the rates. Rent per kilowatt for data centers continuously drops down, down, down. Yet we are at the highest occupancy ever in our history. There's less than 1% available.
Zero.
Right?
It's going to be 0% in Northern Virginia for wholesale data center capacity.
For a couple of years,
Oh my
probably.
gosh.
Yeah, and 2% across the United States. And so all of a sudden, it's a seller's market, yet they're getting pressured on the units, yet they don't have full optimization of their portfolio. When I've got 40% of my capacity I never use, and we're out of capacity, something's not adding up here.
And demand's rising.
Exactly. So we have to come up with a way to do this. And so what we tried to do is, how can we go back and use the Cato software that allows us to get access to that stranded power and land it with Cato hardware that is standardized on OCP that enables a Neu.ro platform to serve AI workloads to everybody else.
And it's multi-tenant. That's the beauty of it. How does this get deployed in a data center? I bet you someone listening to this, Bill, this is all great. How does this work in the data center? It's all multi-tenant ready. So with the platform running on top at Neu.ro, Kirk data centers can put a whole bunch of Cato gear in your facility. It's up and running. And then you say, Bill, throw Neu.ro on top. I've got these 12 racks. Cool. 6 of them are dedicated to just your customers. And then the other 6, self-service. Literally start selling credits, start competing with Amazon and Microsoft. Literally, that's all you have to do. 6 days, Neu.ro deployed on top of Cato, and you just open the doors and people will come in and they will buy that compute, and it'll still be like 50% less than the cloud. And that's something that we've seen. For example, one of our partners has a high density architecture. Now they are using H100s, and they're going to open up a whole bunch of them to a self-service architecture. Now Neu.ro is sitting on top, and we just literally have a self-service function that we enable. This data center partner with their logo and their name is pre-selling credits. So their gear is going to be coming in 6 to 8 months. They've got, hey, in 6 to 8 months, pre-purchase these credits because our gear is going to be coming in. Their forecast is they're going to be sold out of those credits before that gear even comes in, and they're going to be putting in the live architecture. So I'm getting excited about this. The really cool thing about this is not just for one customer, for one person. From a data center perspective, you have the capability to capture a market, not just a customer.
I think it's a niche market right now, what you guys are talking about too, because I was just talking to Peter. He was out here a couple of weeks ago, and what we're trying to solve for is the topology, the MEP footprint and topology based on the footprint that you make is different, right? For an AI data center, the mechanical permutation sounds like it'll be way different, So we're trying to figure out, that's why I want to spend more time with you and understand more about where you guys are going, because I think that there's a asset class that you're talking about that has stranded capacity on the backplane that you're looking to figure out how to use with this technology. But I also think that there's going to be purpose design and purpose built ones moving forward.
Yep.
And for that end, I don't know if the soup's done cooking on what that looks like, but once they codify that design and they take it to the street, who's over the barrel at that point when you're building to something, you realize, oh my God, I'm halfway through this and it's not going to be enough to support the densities that we're scaling to, because as you said, it sounds like densities are going to continue to increase.
Oh yeah, it's fascinating to watch history repeat itself in some ways, right? So the Open Compute project is here to meet the market, right? And our tagline is hyperscale innovation for everyone, right? And that when the Open Compute project was founded, you had a customer, Facebook at the time, who needed something the market didn't offer, and we're all facing that right now. Right? There's tons of demand and the market isn't exactly matching it. So the technology that comes out of the Open Compute project or goes through the Open Compute project is usually pre-market of what everybody else can buy, because we've accelerated the innovation. So where the market says, these are the servers we have, do you want to buy them? Facebook and others said, that's not what we're shopping for. So we're going to take our designs that we know what we can use, and we're going to take it straight to the manufacturers. We're going to skip all the logos that you're familiar with. We're going to remove all the unnecessary pieces, and we're going to get it from the manufacturer into our data centers 18 months faster. So you talk about those servers that are staying in these hyperscale data centers. For those using OCP hardware, even if they use them for 3 to 5 years, they're 18 months younger than anything else that's 3 to 5 years old. So there's tons of great life left in that hardware. And then as you see challenges like AI presents, we're getting it into data centers faster. So there's that cycle of moving things through. The challenge then becomes more towards the MEP side is we have this massive demand. We have a massive amount of heat and energy that needs to be consumed, and the buildings were never built for it. So now what do we do? So then we have partners and member companies that come in, like Accelsius, that comes in and has innovative solutions that says, we have technology that can solve this problem. How do we get it into the market? And how can they adopt it? So we use standard practices, white papers, specifications that end users, no matter what their size, hyperscale, enterprise, retail, whatever it may be, can adopt those standards and deploy this new standard equipment anywhere in their facilities. So Liz, on the cooling side, like what's your lane?
Yeah, it's funny because when we were talking about kind of what we used OCP for, direct to chip has been around for a period of time, but used more in that 20% range, right?
Mhm.
Where it's just super high demand, high density. But so there's some experience out in the market, but there's not really standardization. So Accelsius, as a startup, realized that OCP had 10 years of experience talking about liquid cooling. And what we used OCP for and continue to use OCP for is to connect with other members in the ecosystem, because liquid cooling does not stand alone. We needed to talk with Intel. We needed to talk with all the MEP providers. We needed to talk with the
They don't know that it exists. They're not going to put it into a design. When they come up, someone gives them a statement of requirements for their facility and they need to meet a density requirement. If they don't know about your product, it's hard for them to incorporate it into the solution, right? From the early stage.
Yeah, that, like just the awareness, but also a lot of the questions we've received from really intelligent, leading edge, operators was, what do your pipes look like? What do you need in terms of a flow rate? What do you need in terms of connections? And so, there's one very large company that went to all the different liquid cooling providers, asking them these very detailed specifications that would not happen if you were, installing a UPS or a rack PDU. It's just because it's such a new emerging technology that there's no standards. The way we do it versus a single phase direct to chip company is different. And so working with the OCP and putting out literature that says pipe sizes should be this. If you have to come under floor, better to trench than try and, go under raised floor, whatever it may be.
So these are evolving means and methods that you're trying to get others to adopt as standardization.
Exactly. Yeah.
Stabilize and then standardize and how you do it.
Yeah.
And what's important, I think, is that you can have a big player come in and standardize and say, this is what we're using, and we're, big gorilla, we can take a bunch of capacity, so therefore the vendors support that. But that might not be the best idea. So working within the Open Compute project, really the best ideas rise to the top, because you have companies that partner, not just the piping manufacturers, not just the very innovative direct-to-chip manufacturers. They're all in one room together saying, here's the challenge. What's the best way to solve this? Let's all agree on this is the standard we're going to start to use. And that could be something as simple as a base specification or a guidelines document. Like, here's what liquid looks like in a data center. Those conversations previously would happen behind, and still are happening behind closed doors.
Are they different types of conversations between operators and enterprise end users? Because the enterprise end user is typically building this platform. It's not a cost center, but it's the engine under the hood they use for the performance, right? Whereas if you're an operator, the primary line of business they use to generate revenue is space, power, cooling, and connectivity. And those conversations are probably different because they're running on an SLA, right? So they have a client that's dependent upon them to respond. That makes a difference where I put my pipe and my wire, right? Because if I'm going to put water in my white space, I have to make sure I'm doing it without, if I flood my own building, if I destroy my own stuff and it's mine, no one cares. But if I destroy my customers, then they care a lot, right? So there's a difference between those two. Are you seeing a different adoption rate between the two communities?
Yeah. There's enterprise data centers are different than multi-tenant or even like purpose-built single-tenant.
Always have been, and they're the ones that are dragging the other parts behind.
There's obviously some super innovative enterprise facilities that you'll see out there, but for the most part, to some extent, sadly, it's seen as a cost center. It's not given the type of love where, space, capacity, and power are your revenue generators alongside, for example, services. So, to answer that, yes, absolutely. Now, you mentioned something that I want to make sure I bring back, Liz and Rob. Over the past year, yes, liquid cooling and OCP have been around for some time. Let's
13
be honest.
years.
Right. But the spotlight on you both has really changed literally since what I think November, December of last year, ever since ChatGPT took form. And what's been fascinating, I wish I could tell everybody the latest results from the AFCOM State of the Data Center report that's coming out in 24. I can't because I'm going to get in so much trouble. But we did ask questions around single phase and two phase immersion cooling. Let's just say I was surprised.
Explain the difference to anybody that's listening that doesn't get involved with that.
I'd love to. So immersion is kind of that horizontal rack form factor where you are stripping the servers of fans of everything and dunking it into a tank. And there's
in that tank, is it oil?
Dry electric fluid, mineral oil. It's stuff that
it's various
glycol.
Types of coolants. Yeah, there's so many that have not been standardized.
It's not water.
Okay.
Yeah. But then in direct to chip, which single phase direct to chip has definitely led the market, and that's Cool IT. It's been the one that's been here the longest. That is water based, so it's water mixed with glycol, and so that's a cold plate on the server inside the rack, running the single phase coolant through it. And then two phase is basically the same kind of form factor. It's in the rack. It's a cold plate on the GPU or the CPU. Oftentimes now there's this, heat removal on the DIMMs as well. But the two phase uses the vaporization to remove heat. So in single phase, you just rely on flow rate and how much heat you can remove with liquid. But with two phase, you're able to use the phase change to remove more heat. And I spent last week really trying to understand that graph, which I don't. But I can say those words and know that they're true.
Well, you have
Go ahead, Rob.
No, we have the privilege of like I get to be the dumbest person in the room often, which is great because
Pick a number.
we have 12 top level projects at the Open Compute Project that work in various disciplines. And our fastest growing one is cooling environments for these type of solutions. So you learn about things like single phase versus two phase. And, when you go from a liquid to a gas, what happens to the energy? And can you reduce the amount of heat at the chip? And, sneak preview, yes, you can. And so now you have that, and you called it trickle down. And we're kind of like, maybe kicking ourselves a little bit like, okay, this conversation didn't happen as early as it should have at DCAC. But none of us have really seen anything like this before. As Bill said, the spotlight's on us. But we're all new at this.
You're nailing it, Rob, and I want you to keep going on this. I don't have anything to compare this to. None of us have anything to compare this to. Like it's the first time in human history that we're seeing any sort of this level of adoption. And the crazy part here is that when I say we're driven by the market, financial services, logistics, computer services organizations,
every vertical of industry,
they're coming to us and they're saying, here is our data. How do we ask it better questions?
Well,
how do we make it work?
It's really important. You talk about like this wave that's coming. So there's two major waves. One is these tons of chips that are coming.
Mm-hmm.
Well, the infrastructure is not here for them yet.
Exactly.
Yeah.
Like you bought the car, you bought the Ferrari, you don't even have a house yet for it, right? There's no garage. So we all have to build the garage still.
That's what I'm focused on most.
And
there's
there's
two elements to that. Like someone's got to build.
But
you guys have these big fat brains and you have these visions. Somebody's got to bring it to life. And I'm trying to figure out how do we do that.
Let me step one step back and then we can go into kind of the infrastructure for it is. The reason why these GPUs are so valuable, generative AI, we're seeing lots of neat functions and applications of it. 90% of data that we have digitized is not structured. So only 10% of the data that we have created, we can organize and use usefully.
And Rob, side note, structured data, Excel spreadsheets, SQL databases, really nice linear, unstructured data, doctor's notes, emails, things that don't have any structure to it that you can still all ingest into one big data pool.
Right. Perfect. Thank you for the note. So the unstructured data, there's data there. We don't know how it relates to any other piece. You can ask these tools, these models, run them on GPUs and CPUs, depending on your time frame, your goals as far as power, sustainability, all those things. They can make use of the 90%. So now here's the reason for the trickle down.
So that's where you're gaining the most efficiency, it sounds like, in those data set pools.
Actually, it's a little different. I've found this fascinating. I've been doing a lot of reading on just the transformation we're in right now. And there's a guy named Shelley Palmer, and he's one of the top tech voices out there. And he's dubbed November 20th, 2022 as like the origin, because that's when really ChatGPT became public.
Because ChatGPT has been around since 2018, if I'm not mistaken, but it was basically like talking to a 2-year-old.
Right. And if you look at what happened, and now he said that was the origin. Now we're at what they call the generative era. So we're at 1 GE as of November 20, 2023. We've had 1 year, okay? And what that means in between this is that at last year on November 20th was the first time where we went from structured data and be able to say, ask a question, look something up, get a response, like doing a Google search, to a system being able to now take all this unstructured data and create content. Which means that this is the first time in human history where we have to doubt everything that's created because we don't know what it is. So very, very different. But the adoption rate, as Bill was saying, is staggering. And just to get an idea, Electricity took 48 years for it to become adopted by the majority of people.
People were afraid of it too back then.
Well, there was some science behind that with Edison and the electric chair, right?
Yeah. Well, there you go.
You didn't do any favors.
Shocking.
Yeah.
So then you've got the phone, which I believe was 23 years. And then it goes into the PC, which was 14 years. Then it goes into the cell phone, right? And the cell phone was 7 years. Then you went to the internet, and it was really 6 years. Now you go down to cloud, and it was 5 years. And now you look at AI, less than a year to have global public adoption. That's the pace at which we are unprecedented right now. So, and just to get a little more data here, just to widen out a little, our industry in 2021, we put these numbers out at iMasons. We had 7 million data center locations. These are unique street addresses for buildings, right? From very small things back to gigawatt campuses. They had 105 gigawatts of capacity built. This is UPS generators, being able to supply that. And then the consumption was 594 terawatt hours of energy every year. That represents 2.4% of the total energy draw. That's digital infrastructure for whenever it leaves a device and does stuff. Everything in between that is digital infrastructure. Now you look at Mark Ganzi and Digital Bridge and others predicting what generative AI is going to do. At a minimum, there's 38 gigawatts of new capacity in the next 5 years, just around generative AI, okay? But they predict that our infrastructure is going to triple. And we just talked about all the constraints we've got, but the tripling of that, and now imagine globally, what's the largest data center market in the world? Loudoun County, Virginia. And so in that one, they have 0% capacity available. Okay, now let's take Africa, India, and LATAM. I was just over in Africa.
New Zealand, Australia, all these emerging markets.
They're all growing.
Right. Every one of them doesn't have the
power.
capacity.
What makes them?
They don't have infrastructure yet. They don't have digital infrastructure. They have power, right? They'll generate more, but they don't have data centers. They don't have all the network connectivity. So when you just Africa is an example of that. I was shocked. In 2019, when I was in India, I found out they had 400 megawatts of total data center capacity. 400 megawatts for 1.3 billion people. That just blew my mind. Well, today they have 800 megawatts with 1.3 gigawatts in the pipeline. It's going to go to a 10 gigawatt market very quickly, right? Africa, okay, 1.4 billion people. It has 350 megawatts total for 1.4 billion people.
Wow.
They have 54 countries across that continent. So it's totally different problems, but no matter what, all of this data tsunami is hitting everything. It's just that some people are prepared, some are not, right? And even the ones that are prepared in the more established markets don't have access to capacity. They literally can't get transmission lines to get power to where they need it, which means they have to shift and change that. We're going to go elsewhere in other places that have power. But this, it's just unprecedented again. I keep using that word, but on almost every element.
It has been for a few years. Like you said, Missy one time at DCAC got on stage, and this is 3-4 years ago, and she's like, hey, we've made more content in the last 18 months than we have in the history of the world.
Yeah.
Right. And I can't imagine how much we've created since.
Well,
right?
I think I got to remember these metrics. 2023 was the banner year, I believe, where we created more content than all of the time in the past, right? So we've gone, we've condensed that. And back to Dean's point, he's condensing this evolution, and even the evolution of GPT and generative AI. GPT-3 was called a single mode model, right? Where you enter in text and you get text as an output. GPT-4 is known as a multimodal architecture, where you can throw in video, audio, images, and that will generate an output content for you. Obviously, it's going to consume a whole lot more energy, but you're already talking about, within the era of generative AI, this singular evolution of the way you can both inject content or an image or words or thing, and what you can actually get back from it. So the use cases, and we don't have time for this. Like we've been working with everyone from, fast sports cars to the world's largest, cosmetic companies. The use cases here are extraordinary, are absolutely extraordinary. There's pretty much no limit on what you can apply when you use data, and if you have enough of it, to a business use case and scenario.
Well, there's a limit, right? There's a limit on infrastructure and power, right? So, but I mean, we're going to tie it all back. I'm going to tell you why this is such an important topic for a person like me that focuses more on space, power, and cooling, right? And those that listen to this that follow more of the space, power, and cooling, because this is an intimidating topic for a lot of people, right? And we're going to have a lot of these conversations to deconstruct these high level parts, because I'm hoping that there are people that listen to this podcast and listen to it twice, or maybe take some notes, because at some point we should be able to tie it all back to everybody else. We know it's hitting everybody from the consumers. That's easy to identify, but how does that hit us as the people that are in the ecosystem bringing this product to life, this home for the cloud? And it was hard enough to build a home for the cloud. How are we building the cloud? How are we building a home for AI? And I'm laser focused as a group that just focuses on human beings that are going to be the part that brings this product to life. I mean, Dean said something interesting that I thought, like, why aren't they just holding on to these racks, these horses, for longer? And, you can't get ahead when you're struggling to get even. Everyone's moving so fast that you're like, just refresh. Do you think that we don't adopt that same approach to humans? I mean, every company, you have people that are like, where they're going to be gone in 3 years. We're going to grind 2.5 years out of them. The last 6 months, they're going to be miserable. They're going to probably, at the end of that 3 years, go find another job, probably maybe a little bit more title, a little bit more money, a couple more vacations a year. They're not going to be any more fulfilled by what they're doing, but maybe now the juice is worth the squeeze because they're getting paid differently, right? But how do we figure out a way to slow down and repurpose people like you're repurposing, the infrastructure around this? And that's because I'm going to be a part of trying to solve for how do we improve people to be able to solve for a much more sophisticated requirement. And that's what I'm seeing that we're getting, out kicking the coverage right now. And there's a pent up demand for people and talent, and there's not enough people that can operate at this altitude and airspeed, right? Which is why it's not important enough for you to just know what you're doing and do long division faster than everybody else. We have to figure out how to educate people to understand, because if they don't see how it ties back to them, then they're just going to continue to close the door on this and be like, that's a conversation for other people on to play in that world. The reality is we are all playing in that world now. And we all have to understand this at a whole nother level. Don't you agree?
You can't think about data centers in the traditional way that we've been thinking about, for the longest time. I'm lucky enough to call myself a native to this industry. I went to DeVry. I got a network engineering degree. And I was 21 years old, and I was literally, racking, stacking stuff, putting firewalls in, making sure airflow was. I was working in a data center before I even knew it was called a data center. And we've seen this extraordinary evolution from, this level of inefficiency to an extraordinary level of efficiency where we have to operate, low PUE and so on. And to your point, Kirk, how do we nurture this evolution for traditional people, right? Whether it's people exiting the military, people that we work with Dean and I, over at Infrastructure Nations with the Capstone program that we work with. Our mission as people at the forefront is to help people break the paradigm of what a data center looks like, because maybe people don't even know what it is in the first place.
Yeah.
So the most important thing at the basis of it all, it's still space, capacity, and power. It's still density. It's still locations. The basis and the principle and the foundation of our industry is the same. What's changed is what's going inside of it, right? How do you make it more dense? How do you literally work with your organization to improve density levels, sometimes by 2, 3, 4x? How do you think about a design perspective? Do you work with OCP? How do you start to look at liquid cooling from a there's air cooling is limited.
Yep.
Period. There's no way that you're going to be able to support an advanced AI architecture. V100s, quite possibly so. But if you're starting to go with and H100 architectures, a full rack of H100s, full stop.
Well, let's dive into that just a little bit so that, you talk about people on the infrastructure, power, and cooling side, like, without getting into the total physics of it, which is definitely above my pay grade, is like, why is that, right? Like, you can only move heat with air so quickly away from something that generates heat.
Right.
And the generation of things that we're installing in data centers today is the equivalent of taking a Weber grill, turning all 4 burners on high, and sticking it in a data center.
Oh
That's the amount of heat we're talking about.
Oh my God. I just got
Right. Like put 3
cooking with gas.
Right. Put 3 Grand Tetons, which is the Meta, public open source name for their 8-chip GPU sled. Put 2 or 3 of those in a rack multiple times over. That's a lot of Weber grills. That's
so
a
that
lot of
changes
heat.
the entire design and architecture of a data center.
Well, I was
Don't
looking,
you agree?
I was looking through my notes. I was not on social media. I promise. Everyone's looking. Why is Bill looking at his notes here? So why this is important, what Rob is talking about and why Liz is important, what Dean is developing. A single Google search can power a 100-watt light bulb for about 11 seconds, consuming about 0.3 watt hours of energy. A single GPT-like, and this is research that we've done at Neu.ro with running these types of workloads. So again, AI transparency, happy to publish these numbers. A single GPT-like session is between 800 to 1,000 times more powerful than that single Google search, consuming about 300 to 400 watt hours. And to put it in context, that is enough to charge this cell phone right here about 60 times. And GPT-4 itself is about 100 times more powerful than GPT-3. But I'm actually not done yet. That Google stat was from 2011.
Mm-hmm.
Dang.
Okay, so you better believe that they're more important. And if you remember that GPT, that single GPT instance, they don't process them in instances. They process them in 6 to 8 queries per process. So really, you're talking about in the kilowatt range per GPT instance of what you're trying to process. Every single time you've gone over there and told ChatGPT to tell your kid a Paw Patrol story, or something like that, make it, because I do that all the time. It's actually really cool.
Paw Patrol.
It is. You could like do Paw Patrol mixed with like Batman. Like, how did Paw Patrol save Batman? It is the best thing in the
do
world.
games
I
and
gotta do
stories.
that.
It's really
I
good.
know. I recommend
It's really
it.
good.
Nice.
But every single time I do that, in the back of my mind, there's this consciousness that I'm consuming a silly amount of power.
Plus the water that is used to
Yeah.
cool that, to reject it. That's where you're going probably, right?
Yeah, and just like the funny things that we think about, like teaching our kids to turn off the faucet when they're brushing their teeth or turn off a light when you
Simple.
leave the room. Yeah, and these are things like I feel guilty when I don't do it, but then I'm like Googling all day or I'm streaming content and I'm not even thinking about it. It's like this wall of disbelief of, what the digital usage of electricity and water is. And so when you were saying about what can we do as people, I think, Dean, you're talking about the demand that we can't stop. Like people aren't going to not
No.
Yep.
do something that helps them earn revenue for their business. And you talking about the lack of power, like we can't build power fast enough. So the people inside need to think about how to do it smarter, how to like turn that faucet off, how to turn that light switch off. And I think a lot of it is, yes, liquid cooling is needed for some of the latest generations of chips because air can't cool them. But also, why are we still using air at such great scale? I mean, it's 40% of a data center's energy use. Like, let's be thoughtful about how we're using the power so that either we use less power and don't, burn the earth to the ground. Well, there won't be ground, but, or thinking about reallocating it. So like there's other demands for the compute. So take the power from the cooling and give it to the compute. I think that's, how we need to think more creatively. And, this morning on NPR, we're like seconds to midnight on they were talking about COP28 and we're seconds to midnight on stopping the 1.5 degree climate, warming. And it's just like, we're really at a bad place and data centers can make a big impact. Like we're in an industry that can help a lot.
That is growing faster than almost any other industry.
Yeah.
Because of every other industry.
Because of all the consumption
Exactly.
from it.
But
Yeah.
it's scary. It's scary, right? We have been conditioned that air cooling is enough. That's enough. Like we've literally conditioned any data center that you want to look at. Where
There's a great pun in there somewhere. Conditioned and air.
well done.
yeah.
Rob,
I'm
well
not that
done.
quick, but it's there.
We'll come back.
We'll
to
workshop
that.
it.
So he has a
We've
limit
been
after
air
all.
conditioned.
I got you.
Yeah, but that's the problem, right? And so we have to get over this fear and experience and explore OCP type of architecture, liquid cooling type. Because here's the thing, for the data center perspective, your customers are driving this conversation. So if you don't do it, someone else is going to do it. Like my partners, the people that are deploying Neu.ro, they've gone from an air-cooled infrastructure saying, I understand what my market looks like. I've spoken with my customers. I'm going to put in this liquid cooling or rear door heat exchanger and create a hybrid ecosystem where I'm not ripping out everything.
And by the way, I think it's really important that we don't let the pendulum swing too far.
Sure.
Because we keep talking about that 80-20 rule, right? So the 20% of this is I have to have high performance compute, right? GPU type things that require a different medium to be able to extract the heat. And just to go to Liz's point, a simple analogy is imagine if you're fanning yourself with something versus jumping in a pool.
Sure.
You dissipate heat much faster with liquid directly, right? Grabbing that heat. It's like 1,000 times more effective or something.
Yeah.
So there's a big difference in that. As you get denser, it just makes perfect sense that you use some type of liquid that allows you to extract the heat. But I think what's also important is that there is a natural progression here. And I guess I'm the oldest in the industry now. It's terrible. 34 years, right? I've been doing this.
Dang.
And I've watched every one of these waves. If you think about it, what's cool is I've been part of 7 planet impacting technology advances in my career. Think about it. PCs coming back in, right, to the launch of the internet, to cloud, to mobile computing,
devices,
to it's just really cool to watch those things. But also, everybody has predicted this in the past that, oh my God, it's going to go like this.
What do you think the biggest lag is? Is it solving for the cooling? Is it solving for what you guys are doing with infrastructure and software? What is it solving for, like standardization?
Well,
or is it still power?
Oh, I don't know what it depends what plane we're talking about. Power is certainly one right now. The next one that'll probably be on a technology standpoint is network, right? All these nodes have to be connected to each other. Network is going to be
the easiest part.
It's going to be a huge bottleneck, but
the amount of data moving.
We can prevent that swing, I think. We can mitigate the swing if we are behaving more like prosumers, where we have the voices of the end user, not just accepting what the market wants to deploy, right? Everybody's really excited about GPUs. We're going to sell a ton of GPUs. Okay, well, that will probably continue for a period of time, maybe a few years. But if you overshoot, what's the cost of that? So if the users are influencing what's being built, then we can more accurately hit the market demands and not overshoot. So by standardizing and having these open conversations, we can do that.
So, and by the way, this is why OCP is so important, because it brings everybody to the same table and you have those discussions about how that can be done. And you have the power of that community to go back and do standardized things. But remember, make no mistake, we're talking about AI side. And when we're talking about that pendulum, cloud isn't slowing down. Remember all that stuff around Africa and India? They don't have cloud capacity. It's not even AI yet, just cloud capacity.
Yeah, because the demand's not there?
It's because first off, if you take India specifically, they passed a rule in 2020, I think it was, about their data protection, data sovereignty. That forced all the cloud players to say, I have to have stuff in India. And so that's why this thing is ramping up. Well, that's happening in all these other countries, which means that now it can't be served from the US or Europe. It needs to be served locally. Mm-hmm. So that's just straight up cloud and data, right? Processing. Then you add AI on top of it all. Okay.
Are all these problems that we're keep going? Sorry, Dean.
And then if you look, what I'm worried about here is that I want to make sure we don't have people walk away from this saying, oh my God, I have to have everything liquid cooled in my data center. The reality is you're going to have a hybrid environment no matter what. Unless you're doing a purpose-built data center that is for AI-specific high-performance computing, where it would just be liquid only. But for everything, take the retail data centers, take the co-location environments, like all of them, they have to figure out how to serve multiple customers that are going to have air and liquid. You have to come up with a way to be flexible to do that. But guess what? You can reuse the infrastructure to provide liquid cooling solutions at higher density for a portion of your data center. But you need the flexibility in the design to be able to accommodate that. I'm going to roll these liquid cooled racks into here. I'm using the same cooling infrastructure that I was using for air, right, conversion to deliver this stuff. So people need to think about how do I accommodate density as well as all of the base load, which is that compute side for cloud, and all the other workloads that are non-GPU based.
But let me pause you because I think that ties back to where my part of this is, right? We know what you do and we know what you do and we know what you do and we know what you do. What I do is try to figure out how to put human beings in the solution, right? Because we are the consumers. And I think that as we approach the fifth industrial revolution, right, it's like cheeseburgers. I mean, think about human nature. What we're talking about here as consumers is we can't get enough of it, right? I mean, cheeseburgers are legal. I could buy them anytime I want to. Doesn't mean I should eat them all the time. I think, right? I mean, but we will become more, we will have a healthier relationship with our technology as we evolve. That's what the fifth industrial revolution is about, right? But going back to what you were just talking about is there was never really a big need, right, for everybody to be in the same room together because big fat brains would get together and say, these are the things that we need. And people that would be like, well, this is the only way to solve for that. And then the design engineers would put a stamp to that. And then they would take it to the street and the rest of the market. Because, you know, if you look at 90 cents of every dollar spent in this infrastructure, in this industry right now is still really spent on the CapEx side, right? So we have to solve for building that bridge between all the nerds that are advancing the innovation, because the innovation of technology moves way faster than the innovation of humans, right? So we are still here with bad habits, trying to get caught up, and people are becoming and growing more unfulfilled, maybe even unhappy with what they're doing. In many cases, maybe they're not healthy, right? Because they're like, I'm doing everything I can, but I can't get ahead because they don't understand what they need to be going. They're going to the puck instead of where the puck is going. So I look at this conversation and go, there's a time now for us that we're on the pick and axe work, that we're just building stuff and standing it up and saying it's yours, fill it with whatever you want. Now we have to understand, wow, we need to understand what that's going to look for in a year from now and 2 years from now and 3 years from now. Because like if you were at DeVry, you would have never known when you were graduating that the job that you were going to have today, I mean, it didn't even exist then. And try to imagine now, what does that change society from an educational perspective, knowing that technology is evolving so fast that whatever you're in college for learning today will probably be obsolete by the time you graduate. So what do I need to be studying for? What do I need to be learning, right? Because I'm going to continue to tie back to human beings because that's all that I'm in the business for. But I am leading a business that is trying to become the tip of the spear in understanding what that AI environment looks like. So we're imposing this level of knowledge on ourselves where I'm like, I can't afford to just show up after the fact. I need to know where the puck is going. And this conversation and what I wanted to stop for is so those that are listening, they're like, I got lost in the mechanical stuff, or I got lost on standard. I want them to realize that you have no choice. If you're in this space and you want to have a fulfilling career, you better start paying attention and asking more questions, because we have to solve for this. Like majority of us are on the solving of this stuff. The electricians, the plumbers, the people that are doing concrete and steel. Those are the things that build the home for the cloud and the home for AI, right? So we need to understand, like, what do we need to be doing as an ecosystem to solve for the innovators like yourselves that are bringing this really amazing thing to life. We know what it does on a micro scale. How do we bring it? How do we unleash it? And it can't just be based on technology alone. Humans have to catch up, and we have to do a better job of having these conversations more prevalently so that people can pick it apart. Because, I mean, maybe there's 4 or 5 conversations before it clicks with people. Maybe someone has to listen to this one 4 or 5 times before anything clicks.
I've had to listen to lots of conversations that I didn't listen to, right? That didn't sync. Access to information is huge, right? So all the work that goes in the Open Compute Project, our 3,000, 4,000 plus volunteer engineers are sharing what they know to move innovation forward. They do it in open calls that are free to access. You do not have to be a member. Quick plug, you can go to opencomputeproject.org or opencompute.org and get access to that. You can download all the work that they've produced on our database for free. You can digest that. We're working towards more learning things, and there's other organizations that are doing that in different areas of learning. But one is access to the information. The other is behavior change, right? Like, don't be afraid to be a beginner in something again. I've had to teach myself that lesson many times over. Is like, well, I'm pretty good over here, and I'm kind of comfortable. I'm okay. But every time I become a beginner again, I found something new. And that's always served me.
That's
really
because
well.
this industry reinvents itself faster and more aggressive than any other industry.
Well,
Again,
it's only going faster, right? And I don't care if you're in tilt-up concrete. I don't care if you're in steel manufacturing, electrical, mechanical. It's changing faster in our industry than it's ever changed before.
Sure.
Yeah, when we went to DCAC, that's what I was thinking about in terms of kind of the audience, and like it is a show about, or an event about people. And I really believe that information is power, especially at the individual level. So if, people who are listening and looking at what they need to be doing in their careers, a year from now, 5 years from now, the more access they have to information from other people in the ecosystem, the better a decision they can make. So organizations like OCP, where you can join at an individual level and you can have conversations like business cards left at the door. And it's really just an open, honest conversation with really smart people that there's people, at Intel or NVIDIA that I met through OCP that would have never talked to me otherwise. But I said like, hey, I joined, or, I made them feel like they talked to me. And then they do, and you learn from really, really smart people. So I think just, it's not necessarily like, what do you need to go back to school to learn? But like what you can do tomorrow is just get on a call or reach out to someone.
That's what I was trying to say. Yeah, go ahead.
I think there's another simple thing to this, which is we're in a gold rush.
Yes.
Yeah.
Well said.
Who makes the most money in a gold rush?
big guys with the biggest machines.
The ones that actually make the picks and shovels.
Mm-hmm.
Supply all of the different people. This is exactly what data center capacity is. No matter
said.
what, there's more and more of it needed, which means that there's lots of job opportunities and we don't have enough people, like you said. So I think that first off, people need to understand a little bit more about what it is that's going in that data center, what's changing.
I agree.
But also don't get overwhelmed with having to learn all of it.
Right.
Because first off, there is a flood of this, right? We've been consuming this infrastructure like at my life for 3 decades. It takes a while to go back and have it sync. But there are basics in this that you can actually have. Mechanical, electrical, construction, operations, supply chain. Like just think of the basics to deliver capacity. This is your human capital. And we don't have enough people with that. Second point is that here we have AI that is going to have the most disruption in jobs and people in the history of humankind. Jobs are going away.
Yeah.
Suddenly, I can use generative AI instead of calling a lawyer. I can go get a better diagnosis from them than I could from a doctor. Like that, there are huge implications.
I could talk to AI and ask what I should do with my data center.
Yes.
You could give it math and be like, am I designing it the right way or is that the most efficient thing I could do?
And the immediate speed. But the key in this is that the people that are going to be disrupted have to think about, well, what's the next one? It's kind of like when the printing press came out and all these jobs got impacted. Well, lots of other jobs are created.
For sure.
Well, I'd say in our industry, it is literally the best kept secret out there. We're the fastest growing in the world. We have the most demand that we cannot fulfill, and we don't have enough people.
People don't know about this industry. I'm trying to change that with this platform and other ones that we're going to do. But I'll tell you, like, I think that if I could get like an Elon Musk on this podcast, and I don't say that because he's a celebrity, but think about this. Cars that he builds need to be plugged into a wall, and that wall needs to provide power, right? Now, so do data centers. So this is something that he's so involved with already, that with what he's doing on AI and what he's doing with vehicles and what you were talking about earlier in terms of the climate, we have no choice. We're going to have to adopt another method of power, right? Or we're going to have to limit what we're going to do as consumers, right? One of the two.
I don't think that's going to happen.
That's not going to happen.
Yeah.
So that's what I'm saying. There has to be somebody and it's got to be a disruptor. Like there's only so many Elon Musks in the world that could go and change an entire industry, like what he did in the automotive industry. Now every manufacturer probably has a battery car now that they're making. So if we could get someone of that magnitude who's like, look, he's got a satellite system for connectivity. I mean, he's got battery cars. He's got investments into AI. Everything requires power, right? So at some point, we're going to have some big person who comes in and says, all right, and rolls up his sleeves and be like, I want all you nerds to tell me everything the problem is. And then he's in, someone, if it's not him, it's going to be someone who's going to solve for the power, because no matter how good you make your AI and how efficient the infrastructure is from a sustainability perspective, and how bad you are being able to aggregate the needs and standardize on a market so we could solve for this as a performance, and what your cooling will do for that, if we don't have power, none of that will matter, or if we don't have labor. And I think that we have to first push this industry out to where it's not as, there's still a lot of military people that I engage with that don't know about this industry, and it's the best kept secret, sadly. And then my kids are in college. I talk to them all the time. Like, does anyone talk about this in their careers when they're going to graduate? They're like, no, they're going into agriculture or this and that, but no one's talking about getting into data centers. But that's why we have to make it cool, and AI is what ties it together.
Data centers are cool. We don't have to make it cool.
You're right. I do. I make my living here. I love this space. Most of my friends are in this space, but it's not to a college kid cool yet. Like they don't see themselves being able to go for a career because the plank changes every month. Like I could get into this and then that job could be out of
Kirk, this is pretty cool. We're in your basement, man. Look at that.
I know. My mom's upstairs. She'll make meatloaf.
That's right.
For everybody.
Oh my God.
Meatloaf. Mom, meatloaf.
Oh, I want Kirk up on my that's delicious.
But do you understand how, like, I'm trying to tie what you have your problem, and like you said, we're all purpose-driven. Everyone is so consumed on something that's really, really important to them. For me, it's like, hey, innovate all you want, but if we don't innovate human beings and we don't make them healthy,
Can't deliver it.
we're not going to deliver your product. And you need electricians, you need plumbers, you need tradesmen and craftsmen. You need people to go build transformers. You need people to go build all the components that go into this stuff. How do you get humans that want to go from the homogenous construct of industry that society is pretty much made obvious to all of us from banking and healthcare and whatever. And high tech seems like it's just too distant for other people to touch. You in this conversation, you four are going to be able to bring it back, or I'm going to help try to tie it down to where humans could use it as a stepping stone to get closer to technology, not just as consumers, but as a part of their career. Because as you said, there's going to be a lot of jobs that are wiped out, right? But there'll be new ones created.
Yeah, the car saved the horse, right? I mean, we're gonna experience this evolution together, whether you like it or not. I want to touch on that people aspect, Kirk, just a little bit. Where have we seen the most success? Where have I and Dean and everybody how have we gotten people in through the door? The capstone program that we've done is special because we've learned that going up in front of a group of students one time is great.
Fleeting.
Right? To get finals, dances, all this other stuff, it's just not going to stick with them. But having a chance to be with them for an entire year in a multidisciplinary type of approach has been revolutionary, I think, because what we've done to these students, and they're everyone from architectural, engineering, mechanical, computer, yes, literally across the board. We've shown them, all right, here's an app that's supposed to support this many people in year 1, 3, and 5. Build a data center, like from the ground up. And I mean everything that needs to go into this facility as well, like the walls, security, the connectivity, the racks, everything needs to go in there. And what these students have had a chance to do was apply the foundational knowledge they've learned throughout their schooling to data centers. And all of a sudden, that's when we've had the most aha moments. I mean, you correct me if I'm wrong, is when these students are like, oh, that's how I can do this. I mean, one of our students, Jai Huntley, this is what we're doing our first, the inaugural capstone course. She was one of my students. Mm-hmm. She's currently at Edge Connects, right? And I had her up on the keynote stage at AFCOM Data Center World and asked her point blank. It was a little moderated fireside chat. Would you be doing this right now? She's like, no. I had no idea that I could apply electrical engineering skill sets to now helping customers on a massive scale forecast power demands. How much rack density do you require? Where should you deploy your next workload? That's what this person is doing, and they're making a very good earning and great living. And that's what we've seen a lot of times happening with the students. But the challenge is that we're not just, competing against, other data center partners and amongst ourselves. We're competing against everybody. When I was teaching a group of students for Texas A&M Prairie View, was a Latin serving organization, there were 2 students, this was back when I was at Switch, that I kind of wanted to hire because they were really great kids, young adults. And I should say that, yeah, young adults. And I remember going to them and like literally these would have been great salaries with a great organization, right? That you would have been able to grow. And their responses to me were like, Bill, this sounds amazing. Blue Origin reached out to me. So I'm going to go build rockets with Jeff Bezos. I'm like, how am I supposed to compete with that?
Yeah.
Kind of a difficult one.
Or the other one was, I'm going to go work at Sandia National Labs and research advanced molecular architecture and how I can apply my mechanical engineering studies to new machines. And I'm like, dang it. I mean, these are really cool jobs that are going to give these people careers. So, there's pros and there's cons to it. But from, in working with Overwatch and other military personnel, and having a chance to actually speak with quite a few people over when we were in PTC in Hawaii, big naval base out there. And I've learned this. I'm not military, but obviously thank you for the service for anybody who's done such extraordinary things for this country. Their foundational knowledge and the experience and the rigor that they've gone through, whoever needs to hear this, you belong in this space.
Right. Man.
Yeah. You if you
please.
Yeah. You hear this echo of people just chamber, you really do belong here. And maybe this isn't like competing with you right now, but that's where you have to start asking questions. Where can I inject myself? Where can I become a force in this industry? Because you have, what is this? This is from a movie. You have a certain set of skills.
Yeah.
Liam Neeson, that's it. You have a certain set of skills and you can apply them.
And you don't have to be the most interesting student at the top of your class, right? Those exceptional individuals are going to be in massive demand, right? But all industries right now, it seems, very few don't have a massive demand for talent. Whatever talent means for that person in that role.
You're saying they don't have a demand?
They do. We're competing.
Massive.
Yeah, massive. So data centers are competing against all these other industries for all sorts of different talents, right? And when we were at, what was hilarious, I'll just double click on your point about skills in the military. We're backstage at DCAC getting ready for a panel, and David brought by a group of either recently transitioned or new to transition military folk. And I said, well, you guys all had like different MOSs, right? Like you all have different jobs. Like there's a space for you here. And they're like, we're all Navy nukes. And I was like, oh, they're like electricians. I was like, oh, where would you like to start?
Yeah,
like,
exactly.
Anybody in this room give you a
Dean,
job?
listen, to that point, those young adults came in every year. We try to bring in as many as we can, because the beauty about podcasts, and like we were talking about, how do we elevate the industry? First, it has to be, I mean, I know you all publish with Data Center Knowledge and Frontier and those places. I mean, we all read that stuff. My thing is credibility is everything. Like Dean was one of the original rock stars when I started in this industry 20 years ago, and now I'm sitting with him, right? So that's a testament to all these other people sitting on a base. I use the podcast platform because it's unfiltered. Everyone will listen to you and they can form their own trust in you. And that trust is what's going to allow them to have confidence and better understanding in these things. And unlike a conference, this podcast will be broadcast to Naval Station San Diego and Hawaii and Norfolk, Virginia, and all the other military bases in the middle. And hopefully those like 6 young adults we brought in that are all getting ready to transition, like it doesn't take much, but Dean was literally within a few days was sending emails out to the number one guy at Apple, the number one guy at Amazon, the number one guy at Facebook and Google and Microsoft. And I mean, can you imagine rolling into this industry that you don't know anything about, but someone tells you that military people are welcome here. And then you have a person that's one of the big celebrities in the space who's personally reaching out to the biggest celebrities in this industry and saying, not only do they want you here, but they need you here, right? So Dean, kudos to you for what you do that. Plus the commitment you make to veterans on infrastructure masons. And like I get the privilege of working with Tony every now and then, submarine captain, who I got a ton of respect for. And he's trying to put his heart and soul into trying to help get as many veterans here too, because those veterans already have a skill set, right? And their mission critical background was measured in mortality.
Absolutely.
Right? And I can tell you right now, I've worked on panels before where they tied a rope around my waist and I stripped down and they had sound powered phones and guys with sticks. And yeah, man, you got to do things sometimes when you're underway that you don't pull into port just because you had something fit. I mean, you got to get up there and fix stuff. So the unique skill sets that they're coming with, it's more of a fundamental foundation of character that they're learning, because from that you could build any sort of talent from it, I guess, by learning through immersion, right? Just being around big, smart brains.
You can't learn that in a textbook. And I want to make sure I emphasize something that Tony brought up to me. A lot of us predefine armed forces, transitioning armed forces people as technicians and operations. They do a lot more than that. I mean, you're running a sub. You're running this is leadership skills. This is strategy. This is planning. This is supply chain, like all of the other roles. So don't pigeonhole, right, the military armed forces into specific roles. You need to back up and look at their capabilities and what they've learned, because like you said, there is no experience like dealing with that stuff yourself.
Sure.
The conversation goes both ways, right? Like the industry needs to be aware of those resources and people. Yeah. And the industry has to be educated on what resources they come to the table with and be ready to accept them and put job requests out there that match the description of what is going to align. That's one piece of it. And not just putting the onus on the talent and labor out there saying, data centers are great, come join us. Well, the data center industry also has to be adoptable to those talents and their background.
I think it has to be described a different way. Data centers are what changes the world. Everything begins and ends in a data center. Anybody with a phone in their hand is touching how many data centers a day, do you think? I'm sure one of you nerds has the ability to bring...
That's a good metric. We gotta get that one.
How many data centers are touched today just by e-commerce or social media or video, downloading or upload? So everybody's touching data centers every day. They just don't know it because everyone thinks of the cloud, and the cloud is a data center. It's like going into a Home Depot. Instead of rows upon rows of home improvement equipment, it's like cornfields stacked up with your technology. And that is what the cloud looks like, right? But they just don't see that. They don't understand it. So we need to make it to where they're like, instead of saying this is a job description, how would you like to come change the world and unleash AI, right? Because that would be something that I think anybody it doesn't matter if they're in HR or finance or business development or engineering, who doesn't want to go be a part of something like that? They just don't know how to. We need to find a better way to bring them back in. Don't you agree?
So data centers used to be the foundation of the internet. Today, they're a foundation for humanity, right? Yeah. And going back to Tony's example, and Tony, if you're listening to this is a shout out to you, Mr. Grayson. This guy, yes, he's a sub commander.
Just so you know, a submarine commander is a CEO of a $2 billion company.
Exactly.
And people don't realize that when you run one of those warships, what you have on there is hundreds of millions of dollars of talent and weapons, and the machine itself costs billions,
and
right?
Life and death.
Yes.
Period.
And you are the nuclear deterrent. There are some of those submarines that could beach themselves on any country other than America and Russia, and that country would have the third most powerful weapon arsenal in the world.
I'd be okay if it beached itself in Russia.
You don't want that. But do you understand? So when you talk about submarine commanders, that's a very, 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 very small fraternity.
Right. But remarkably, if you ever go and look at our facilities and data centers, I can't believe the percentage of them that are former
I
sub-
just started working with one, unparalleled,
They're
every
humble.
day I'm
Yeah.
just like, I'm
Can't
so
believe-
thankful for you.
And
Sure.
the point that I want to get to is, you're right. Military people are so much more than turnkey electricians. I mean, Tony's an entrepreneur, man. This guy designed a modular data center that's built out of a composite material that he can deliver in 3 truckloads that can withstand a 2x4 flying at it at 250 miles an hour, as well as gunshots. I mean, don't.
Google the videos. It's really great.
It's actually cool.
I mean, yeah, you're welcome. It's Quantum Compass. There, shameless plug. You can send me my T-shirt later.
No. Chris has been I have a lot of respect for Chris's commitment to that product for years. He's like, it's
Mr.
going to
Crosby.
Yeah, he's sticking with it, and that commitment is. Not all leaders play the long game, right? He's been playing the long game for that product for a long time.
But to that point, military people are entrepreneurs. They're brilliant. And when they're given the vehicle to open their minds and their aperture, and when there's leaders like Chris Crosby who will give them that runway, there really is no limit. I mean, Tony came out and said, I've got this really great idea on something that's going to be needed in the market. How do we deploy this thing? And, he got support for it. And this guy built a business model, a data center architecture. And there's nothing that's limiting other people from the military perspective from doing that same thing.
Well, people don't realize that technology will convert secondary and third tier, fourth tier markets into primary markets because the network connectivity, right?
Well, you have to.
Yeah.
Yeah, no doubt. But I think what's important, it ties back to your point earlier, is we all have something that we believe in, right? That we work in. Those are the stories we should be telling these newcomers, right? Or people who are not familiar, we're innovating so fast. It's not just a job, because the job, even especially in this industry, but in lots of industries, you're going to step into this role. It's going to be different in 2 years, most likely.
Yes.
Right. So you have to attach it to the mission and the vision, because things like what Chris and Tony are building didn't exist, and they had a vision and a mission, and they got behind it and built something. This is an industry that's a great place for that. And those conversations are
and it'll
really
change the
important.
labor force. There'll be strike teams that are just focused on going out and delivering those products and stuff. And those strike teams don't exist yet. So that's what I'm saying. Those products, that technology that you're all driving, will change the dynamics of not only the labor force, but tie that back human nature, right? We were all sons before we were husbands or wives or fathers and whatever, right? So it'll change everything that we're doing, not just what we're doing professionally. It'll change everything that we're doing as a consumer.
And there's a lot of people that are willing to help you change and evolve. I think that's the important part here. And for everyone listening, data center knowledge, data center frontier, data center dynamics are great news sources, article sources for things that are happening out there. Infrastructure Masons is a great organization. Heck, just ping, Rob or Liz or Kirk or myself or Dean and just ask a question, and we'll be able to direct you in the right direction here.
Yep, absolutely. Want to help.
And that's an important point here. Is if we don't know the answer, it's going to be ultimately pointed to someone who might. But as opposed to, I think, a few years ago, today our industry has a wealth of knowledge that's going to be shared. Data center world and data center knowledge is owned by a multi-billion-dollar, media organization called Informa, and they are putting in a ton of money into both these conferences and the type of content that's being produced because it's so incredibly valuable. And in that perspective, start reading the trades, articles, white papers, and if something's fascinating or interesting, do you stick to it and just ask questions? And then, learn to be comfortable with the uncomfortable. I mean, complacency in this industry is not ever something I could even utter to somebody. You really need to continuously evolve, but not to make it scary. You just need to ask and find the right people to sort of guide you along the journey. There's plenty of them. And again, even just starting by reading an article, and regarding your earlier question around power, if you're listening to this and you're curious about things like nuclear energy, go on any of those websites that I talked about and start reading about the latest Nuclear Regulatory Commission that they approved in Pennsylvania and Ohio, the first ever small modular nuclear reactors for data centers. for data centers, not just, hey, put these things out here, but for our industry. Nukes, finally, right? SMRs, this is fun.
But that whole part right there, like you're going to have to zoom in pretty big on those parts too, because there's the dichotomy between nuclear weapons and nuclear energy.
Yeah.
There's a lot of learning. There's a lot of learning that needs to happen. Listen, I was there when Chernobyl happened. I was born in Kiev, so and I'm still a fan. Let's be clear on this. I'm still a fan of nuclear power. Yes, I've received every single type of question you could imagine.
Do you have a third nipple?
That
I'll edit that out, man. I'll edit that out.
You're welcome. Well, I don't glow green anymore. That's a party trick that I do miss. But there's a lot of understanding that needs to happen with these small modular reactors, and we don't have the time to go into it. But the questions that I usually get are, is the facility going to be secured? How's the uranium being transferred? What's the enrichment level? How's it going to be stored? What is the impact on the community? All valid questions, don't get me wrong, but every single response that I've heard is, minimal 20% enrichment. If there is ever so much as an incident, the fallout.
Just have them Google how many incidents we've had in the Navy on nuclear reactors.
Right.
How many people have died from radiation since Chernobyl?
We don't have them.
It hasn't happened.
There isn't any, right? So that's why I'm like, it's possible to run them in a safe way. Right. It's just, even if you look at there are incidents that have happened that they didn't fail. There was an incident, but no one was harmed, and all the check measures that were designed to fell into place to protect people, right? So we have no choice. We're not going to be able to keep drilling oil and using, coal. You could plug in your car. You could go get a Tesla and feel good about it. But if you plug into a wall, where's that power coming from, right? And that power, I mean, I don't know what it is in your metric, from 2.5% of our power from a GDP perspective or whatever it was, is dedicated, allocated just for us. That seems low compared to what I would imagine the usage of. I bet you that it's really high in some countries more so than in others, right? That's probably, but I think that cars, probably plugging in cars, has to be measurable as well. And if you look at where we're going, and you look at there's a documentary I saw called Nuclear Now with Oliver Stone, where he does a good job unpackaging those two things. I'm set aside any of your politics or positions on certain things, but if you watch it, it's extremely informative in how we are really designed for that type of power.
The thing is, we have to go back to the reality. We cannot deliver the power capacity without some type of base load that's clean and consistent and reliable. Nuclear is the only other option outside of natural gas. And natural gas is not clean. It's cleaner, but it's not clean.
It's limited sometimes.
Right? And so no matter what, we have to get to a base load that's going to allow us to grow. And so if our infrastructure is tripling, it's being driven by other industries.
Mm-hmm. Exactly.
Right? It's being driven by the electrification and the digitization of everything. And that is leading towards all of the generative capabilities. You just take those three things and the amount of capacity we need globally, it's all tied together.
It's extraordinary. And I actually want to bring in another industry just to kind of bring perspective. I was just listening to this really amazing report where a group of people were asking truckers, like big long haul truckers, would you purchase a fully electric truck? And they're like, we don't have the infrastructure for that. Like, do you understand that for me to complete the same kind of load, I would have to carry between 30 and 50,000 pounds of additional battery capacity?
Yep.
But let's full stop on that for a second. Logging trucks. In Canada, there's about 5,000 of them, just logging trucks alone, right? For them to complete an equivalent amount of load, they would require 12.1 gigawatts of power every single day, right? There is a hydropower plant that's there. There is a hydropower plant that's there right now that produces about 1.1 gigawatts, right? So a hydropower plant will not have enough capacity to support just the logging trucking industry if they were going to go full electric. So the point is, to Dean and everybody else, we have some ways to go. We have, there's going to be an evolution. We can't look at traditional means and methods right now. Solar energy is wonderful, but for 1 megawatt, you require about 10 acres ish, right? And that's something I learned when I was at Switch Data Centers. I mean, they're extraordinary technologies, but they take up quite a bit of space. So you have to start looking at, other types of architectures out there, right? Geothermal limited, right? Wind power, look at what happened with Dominion Energy, especially when it was off the coast, right? That ran into some of its own issues. But like when you start taking a look at SMRs, small modular reactors, these are not giant smokestacks. They're beautifully built underground, very, very effective, 300 to 400 megawatts. And it's clean energy. Now, I'm sure you're going to start to get a whole bunch of emails like, Bill's crazy. This guy doesn't talk about nuclear.
I think it's way more prevalent than you think.
But I think it's an important conversation to have for us to think outside the box that it's not just the data center industry that requires all this energy. We are going to convert. We're going to have to convert.
There's going to be something. What is the tipping point? And I think AI is going to drive it. I think the demand of AI from the consumer will finally get these financial groups to be like, we just need to find someone with a propeller hat and put some money behind
Policy is the thing that's going to change it. And so what I'm actually is promising is that the U.S.
That's the
government...
most painful way.
But remember, the U.S. government changed their definition of clean energy, where it was just renewables, and they added nuclear.
When was that?
That was 4 years ago.
Okay.
Policy-wise, when you think about it, basically that conversion from the Department of Energy was a critical one because it's opened the door. Now, the challenge is for nuclear regulation and management, how do they handle SMRs? Well, the forcing function is going to be, I literally can't get power for industries, not just ours, but industries overall. I have to come up with another way because it's a hydrogen future, but we don't have the infrastructure to support that. So no matter what is the technology that can deliver it today? That will be the forcing function.
Fusion over fission? Is that what you're talking about?
Just hydrogen.
Oh,
overall, like we're taking, natural gas today and like a Bloom fuel cell. You do a software upgrade and it will now be able to use hydrogen. Software upgrade from natural gas to hydrogen, and you can create energy. So, but again, how do you get that hydrogen? First off, that's green hydrogen because it was generated in a certain way to that thing to convert it to electrons. There is no infrastructure in place. I mean, here in the Bay Area or where I live, they're trying to go back and do hydrogen, but this is a decade minimum.
I feel like it took us off track talking about power and stuff because there's still
that's important. If there's one prediction that's going to be coming out of this thing is that we are going to see a shift in policy and regulation and how we deploy power.
Let me tell you what I think the biggest disruptor to all those things are and why I hope that people start listening to more podcasts and less traditional media, because I think most media that people are tracking it's propaganda in most cases, and sometimes it's used to weaponize one lobbying group against another thing, right? Whether it's
division.
Yeah, and I think for us, this is where objective exchanges can take place, and people that know you or me through their own optics could filter how they want to accept this information factually, right?
They trust it or not.
Right. And I think this is a trusted application to get the information out there and then have it shared. And then I think that there's going to be a lot of people that want to scratch the pain and be like, hey, can you back up, Rob, on this whole standardization thing? Or, hey, like this cooling thing, I know that cooling solution isn't static, meaning it's dynamic because the environment it's going to support is kinetic. And you're going to have to continue to iterate off that to support that. So like, I want to start not just talking about the problem, like I'm saying, let's get caught up, but I want to start using us to, like this platform should be allowed to get us ahead, right? Not that you don't have enough forums and there's a million different groups that you're all talking in, but how do we tie it together all as one? Because I think there's a lot of pocketed people advancing certain things, but there's laggards to every one of those things that is going to move the whole thing together up. You get what I'm saying?
Yeah.
This entire conversation has been about rising tides.
Yeah.
And we wanted to float all of your boats. Everybody listening out there, we want to float all your boats right now. This entire conveation for the
well
past...
said, Captain.
Thank you. This entire conversation from us starting this entire chat has been to float all the boats, right? Rising tide. I really do genuinely mean that. Co-opetition, all the marketing fun things that you want to talk about. We really are all in this together.
Yeah.
We really are facing similar issues, if not the same ones. There's a reason why the Climate Accord has how many?
250.
Many of them are competitors, right? Competitors.
Almost all of them.
Thank you. But all of
And
them
it's self-imposed. These are people like, I want to get in on this. I want to make a change.
Self-regulated, self-driven.
Yeah.
Yes.
facing the same problem, right? Again, rising tide. So the biggest thing here that everything that we've talked about and what's really cool about this podcast is that like, I rely on Dean, who relies on Rob,
exactly.
who then relies on Liz's technology to enable all of it. So like,
it's a system. We all work together on that system.